today we are going to look at the experiment number 3 in Labflow, which is separating components of a mixture. The objective of this experiment is for you to get familiar with the different separation methods to separate different components, all the components in the mixture. You're going to learn what it is sublimation, what is extraction, what is decantation, what is filtration. And this is a virtual experiment. You will be given a sample that contains 3 components: table salt, which is sodium chloride, ammonium chloride, and sand, which is silicon dioxide. You will be given a mixture of those 3 components and will be asked to separate those 3 and report the percentage of each component in the sample and their recovery. So let's start by, I will give you a quick overview of the experiment. Then we will do some practice problems to make sure you have the main concepts to help you complete the quiz. And then we'll go over step by step on the report, how to do the calculation and what to be careful with. So let's start by sharing the page of the experiment. Can you see the screen?
Yes.
Okay. You can mute yourself, and then when you have a question, you can unmute again. I think the sound will be better.
Okay, right.
Thank you. Okay, so this is the first, the experiment for this week: separation of components of a mixture. So we talk about the objective. The objective basically is for you to learn the different techniques to separate substance in a mixture. So we talk about the 3 substances that are going to be in your mixture. It will be silicon dioxide, which is sand, here. Let me see if I can. Right. Okay, so silicon dioxide, ammonium chloride, which is a white crystalline solid, and table salt, that we all know table salt. So when you look at the mixture, it's going to look like sand. So the first concept that is important when you have a mixture is that mixtures are combination of 2 or more substances. But what's important is that each substance retains its own chemical identity. You've seen in the previous experiment what is a chemical identity. When you add salt to a cup of water, the water dissolves in water, but you still have salt. It does not change its chemical identity. We have salt and water as we had in the beginning. But what happened, you saw that concept, as I said, in the previous lab, but just to refresh. If you have an iron nail in water and you leave it outside for a few days, you come back and you see rust on the nail. And that is a chemical change. In this case, the iron did not retain its chemical identity. In the mixture, when we separate these 3 components, it will be the same 3 substances that we had at the beginning. Any questions so far?
No, I'm good.
Okay, good. So here there are 2 bullets in this experiment that they want to point out that are important concepts. So one, we already talked about it. Each substance in the mixture retains its chemical identity. So when we separate them, we are going to have the 3 of them with the same chemical identity, no chemical change. And what is the other important concept? The other concept is that when we separate a mixture, we always separate it by using physical methods. We're going to go over that a little bit more shortly, but we always use physical methods. And then they're talking here, what else is important in this? Okay. So this is what we were talking about. We'll talk about what are physical methods more in depth a little bit later. And then they talk about that there are 2 types of mixtures. One is homogeneous mixture. So you will need to be able to differentiate what is a homogeneous mixture and what is a heterogeneous mixture. Heterogeneous mixture is very easy to identify, both actually have no uniform composition. So at least they have 2 different phases. So when you look at the mixture, it doesn't look uniform, and they don't have the same appearance and composition through the mixture. Let's see, if I give you a chocolate chip, is that a heterogeneous mixture or a homogeneous mixture? The chocolate chip will have the cookie part and we have the chocolate part. So it's not homogeneous all the way. Has different properties. If I try the chocolate, it will be different than if I try the cookie. So that is a heterogeneous mixture. Let's say if I have a bowl of cereal, also heterogeneous. Why? Because I have the milk and I have the cereal. Then if I have a soda with ice, I have the ice and I have the soda. So it's no uniform composition through the mixture. They give here other examples like cement is heterogeneous, rocks, wood, and they give others. And what is homogeneous? The opposite. Basically, they are uniform in composition and properties. Sometimes they are called also solutions. And they give an example, air. The air is an example of a homogeneous mixture. Why? It's a mixture of gases. It's just one phase, all gases. You know that the air that we breathe has 78% nitrogen, 21% oxygen, and the other 1% is a mixture of other gases like carbon dioxide, neon, and hydrogen. So air is an example of homogeneous sample. Any questions so far? Just reviewing the outline of the experiment. Okay, so then we'll go over here that they are mentioning here 4 different techniques. See, decantation, filtration, extraction, and sublimation. They basically, if you notice, they put 3 different techniques. Because decantation and filtration, they are 2 different techniques for the same purpose. So we are using decantation in our experiment. So basically, in this experiment, you are going to learn decantation. What is decantation? You probably know, it sounds familiar, but let's look at this picture that they put here. Decantation is the process of separating a liquid from a solid by softly pouring the liquid from the solid without disturbing the solid on the bottom. So the drawing on the left, this one, is decantation. Why? You have the solid right here, see? And you try to pour very slowly in another beaker without disturbing the solid. And that's how you separate this liquid of the solid. That is called decantation. And what is filtration? Is the one that we have next to it. It's also a process, a technique of separating a liquid from a solid. But in this case, you see, what are we using? This one. We use a filter. In this case, a filter paper. A filter paper allows only the liquid to pass through. And this solid will remain right here in the filter. So both techniques, decantation and filtration, are both to separate a solid from a liquid, but one uses a filter and the other just pour very slowly the liquid, and the solid is going to stay at the bottom of the first beaker. Another technique that they are teaching us today is extraction, right here, extraction. Extraction is when you separate a substance in a mixture by dissolving the substance in a proper solvent. So basically, let's look at our example. You have a mixture. Let's say you have a mixture of, in today's mixture, we have sodium chloride. And we know that sodium chloride, the table salt, is soluble in water. But sand, which is the silicon dioxide, is not soluble in water. And we use these physical properties to separate them. So basically, we extract by adding water to that mixture of table salt and sand. We add water, and only the table salt is going to dissolve. And then we can count the liquid, and we separate the solution of the sodium chloride from the sand. So basically, a soluble compound is separated by an insoluble compound. Any questions so far? Okay. And the last technique that they want to teach us is sublimation. What is sublimation? It's the process in which a solid passes directly to gas. So the liquid phase is not shown. Not all the substances are going to have this physical property, but our substance, that is ammonium chloride, sublimes, which means that when we heat the sample, the solid passes directly from solid to gas without showing a liquid state. So there are other substances that also sublime, like iodine, naphthalene, some of them. So basically, we said that mixtures are separable into components by physical methods. I wanted to point out basically what that means. It means that the separation of the components is using the fact that each component has a different physical property. In our case, we know the sodium chloride is soluble in water, the sand is not, the ammonium chloride sublimes, and we use all that to separate basically the components of this mixture. Because each substance will have the properties of the same substance is going to be always the same. If we have table salt and it's soluble in water, it's always going to be soluble in water. So let's look at the flow diagram. This is the procedure. So let's look at this. This is kind of a diagram showing what, if you cannot see well, you can, I'm sure you know by now, but you can make it bigger in your own computer by just tapping the screen. Even though I do it here, you need to do it on yours. Okay. So what do we see here? This square here. This is the mixture that you are going to receive. As we already mentioned, ammonium chloride, sodium chloride, and silicon dioxide. These three components are going to be mixed in the vial. So the first step to separate them will be to heat the sample. You are going to heat the sample, the three components, and the only one that sublimes is ammonium chloride, right here. So if you wait, let me see if I can see the drawing. Okay, if you wait, you have the weight of the original sample, and then you wait again after it sublimes. The difference is going to be the mass of ammonium chloride, but we'll go over that. So basically, we separate ammonium chloride by sublimation. And then what happens? Let's look at here. After heating, we have only two compounds, sodium chloride and the sand. Now we say, oh, how are we going to separate those two? Well, we know the physical properties. We know that sodium chloride is soluble in water and sand is not. So we add water. Here it says dissolve with water. And when we add water, we are going to have here a little beaker. And here we are going to have, let's say, actually you won't have a beaker. You will have, let me correct myself. You will do this in a evaporation dish. So you will have something like that. Let's say here in the bottom, you are going to have the sand, right? And you add water here. So here you are going to have water plus sodium chloride that dissolves. So you are going to decant. Basically, you're going to leave the sand in the bottom and decant to a second dish, evaporating dish, and you're going to decant here this sodium chloride solution. So basically, you separate by the water the sodium chloride solution and the wet sand. So you're going to have in two different places. You're already separating. But what happened with the sodium chloride? You have it in water. You want to have the solid. So you only have to evaporate that and then take the weight when it's dry of the sodium chloride. And then you do the same with the sand. The sand is going to be a little wet because you add water, you dry to constant mass, and you're going to take the weight of that. And that is how, this is just a quick overview of how you're going to separate the three components of this mixture. I want to see if there is a drawing. This drawing, okay. This is, if you are in the lab, you are going to have a setup like this. This one that I draw like that is the evaporating dish. The first step when you are subliming, you won't use the watch glass. Here, this is a watch glass. So you'll have the same setup, but you have the evaporating dish. This is a Bunsen burner, and that's how it's going to sublime. For drying and evaporating, you are going to add a watch glass because you don't want to lose. Sometimes you can splatter some substance and lose, and you have to work very, very carefully this technique, because if you lose some solution, then when you wait, you're going to show that you were a little sloppy, the recovery was not as good. So we'll go over that later. This is just the first quick overview of the experiment. Do you have any questions so far about the main idea of the experiment? Okay, then we'll move to some questions to make sure you have the main concepts, and so you will be ready after you watch the videos and read again this experiment. You will be ready to complete your pre-lab quiz and get an A in your report, hopefully. So let's share now some questions. Okay. Let's see if somebody can answer the first question after we went over some of the concepts of the experiment. Let's read the first question. It says, when we separate components in a mixture, components is each of the substances in the mixture, will the substances in the mixture retain its chemical identity? I think this one you can answer.
That's yes.
Yes, very good. That's an important concept of this separation of mixtures. Yes, each substance in the mixture will retain its chemical identity, will recover the same substance. Exactly. Let's go to the question number 2. How do we separate the mixtures? Do we use physical methods? Let's see. Who can answer that question?
Yes.
Yes, it's important to know that we use physical methods. That's how we separate mixtures. We use the fact that each component has a different physical property. For example, each pure liquid substance boils at a specific temperature at a given pressure. So we may separate two liquids. This is another example. We are not doing this now, but we may separate two liquids that have a different boiling points using a method called distillation. So there are different techniques. In this case, this is very basic, and you are learning just the ones that we went over, but always using physical properties. Let's go at the number 3. What is sublimation? Who can explain what is sublimation?
Change of solid to gas without going through the liquid state.
Exactly. Very good. It's a phase change, exactly as you said. We don't see the liquid just directly from solid to gas. Very good. Let's look at the number 4. Describe decantation. Do we know what is decantation? Let's see if I can answer that.
I think it's a separation of two insolubles where you man,
Close. Remember that when we have decantation, is the same purpose as when you filtrate. Basically, you separate a liquid from a solid. So you gently pour, remember that picture that we have, let me see. You have a beaker here, and then we have another beaker here that has the solid on the bottom, and the rest is all liquid. So basically, you want to pour only the liquid into the beaker number 2, very gently, and you try not to move or disturb this solid. So basically is the separation of liquid from a solid, but it's called decantation because we do not use a filter paper. Sometimes when I wash my lentils, I do decantation. I left my lentils in the bottom and then I try to wash it and pour the liquid one time, pour the other, but I don't need the liquid actually, I'm just washing. But it's kind of the same idea. Does it make sense?
yes.
Okay. So now we are going to see how do we separate the solid sodium chloride from the solution. Remember that at some point we had 2 evaporating dishes in the procedure. One had the wet sand, and the other we decant, we had the sodium chloride solution. But we don't want the solution. We don't want the liquid. We want the salt. So all we have to do is we evaporate the water by heating with the setup that I showed you before, that is in your procedure, you use the Bunsen burner. So basically you evaporate the water by heating the solution in the evaporating dish. Is on the clay triangle, on the ring stand that we saw the picture, that we use a Bunsen burner. And that's all we have to do before we weigh the grams of sodium chloride. And then the last question is describe the process of extraction. When do we use extraction? I mentioned extraction when I said it's the process used to separate soluble compounds from insoluble compounds. When we had the sand and the sodium chloride, we knew that sodium chloride is soluble in water and the sand is not. So extraction is the process that we use to separate soluble compounds, which means when I add water, the table salt is gonna disappear. It dissolves in the water. So extraction is when we separate soluble compounds from insoluble compounds. Does it make sense?
Yes.
Okay, good. So this is how we separated basically the sodium chloride. Awesome. Thank you, Colette. From the sand. So now these are concepts that you will need to know. Some of them are in the pre-lab quiz. So I wanted to go a little bit over those. And now, if everything is clear so far, I would like to go over the report. Which are the calculations you need to do and how to do it, and what do you need to be careful with. So you get an A, which is my intention for you to get an A in the report. Don't lose points. It's a pity to lose points in the report. You should be careful and get all the points. Okay, so let's share the report page. You are not doing this experiment, you already know. This is, every person will get a different sample, so you cannot copy one from another. You need to know how to do it. The numbers are all different, but I'm sharing mine so you know what I did, so you can get all the points when you do yours. So all the numbers are in red, are given. You were supposed to get that information, that data in the lab, but because it's virtual, they are given. So basically, they are giving you here in red all the information and all the data that you were supposed, whatever is in red is all the data that you were supposed to do. So let's look at part A. This is the first thing you will have to do. It says, let's read at that. It says, okay. So remember the first part in the experiment. What was the first part? If you remember, we sublimed the ammonium chloride. So the first part is to know what is the mass of the ammonium chloride. So they will give you the mass of the evaporating dish. It's in black, is here. And the mass of the evaporating dish and original sample, right? So the first, before you sublime, you need to know what you start with, how many grams you had. So the first step, stop me if it's not clear, you have to write here, whatever is in green is what I did. They ask you for the mass of the original sample. How are you gonna calculate that? Somebody can tell me. If they give you the mass of the evaporating dish and the sample, and the mass of just the evaporating dish, what would be the mass of? How do you calculate it?
Subtract the mass of operating dish from the mass of operating dish and original sample.
Exactly. Very good. So for the first thing, what are you going to do? You are going to do, let's say, 38.209
minus 37.26.
minus 37.247. Very good. When you do that, you're going to get this number, 0.962. What is important? In this experiment, they take points out, lose points if you don't add the number with the correct amount of significant figures. So let's refresh. You are doing a subtraction. When you add or subtract, you have to look at how many digits you have after the decimal point, right? So you have 1, 2, and 3. And the other, the same thing, 1, 2, 3. So this is easy. Your answer has to have 3 digits after your decimal point. Your calculator might give you many more or many less, but you have to write the correct amount of sig figs if you don't want to lose points. Okay, so what happens if one number has 2 digits and the other after the decimal point and the other has 3 digits? Obviously, you'll go with the lowest number. Your answer has to have the lowest number of digits after the decimal point. Okay, but that's something you know from the first class. Okay. So then let's look at what else you have to do. How do you, they tell you, after subliming, they give you the mass. So how do you know how much ammonia you have? You do again.
Original
38.
sample.
You subtract, right?
Yeah.
38.209, which is because here you have evaporating dish and original sample. So you subtract from that the mass of evaporating dish after subliming, which is 38.083. Okay. When you do that, you get the number 0.126. And you see, I wrote 3 digits after the decimal point. Then it's going to ask you the percentage of ammonium chloride, always using the same formula. The percentage is always going to be of ammonium chloride is going to be the mass of ammonium chloride, which is this one, right? The mass that you recover times 100 divided by what? The original sample, mass of original sample, which is 0.96. When you do that, you get this 13.1. Now, why did I include only 3 significant figures? Because if you put more or less, you are penalized. Try to get an A. Because this, when I'm multiplying or dividing, I don't look at how many digits after the decimal point. I look at the number of significant figures. And I pick the number with the lowest number of significant figures. In this case, this one has 3 sig figs, and this one has 3. So my answer has to have 3 sig figs. So I write 3.1. Any questions so far on what to write in the report in part A? Okay, so then we'll go to part B. You remember what we did after we sublimed the sodium, the ammonium chloride. We decanted to a second evaporating dish after we add water. So here they give me, how do I calculate the mass of sodium chloride? Here. They give me the mass of the evaporating dish number 2. The watch glass, which is what I cover with, and the sample. But I just want the mass of sodium chloride. So I have to subtract this number. I have to subtract the mass of the watch glass and the mass of the evaporating dish in order to get the mass of sodium chloride. Does it make sense? So basically, I subtract 27.592, and then I subtract 39. You are going to have different numbers, but this is just so you know what to do. When you do that, your answer will be 0.356. And again, because it's a subtraction, I'm looking here at 3 digits after the decimal point. And that's why I add 366 here. And the percentage, I calculated the same way. The mass of sodium chloride times 100 divided by the mass of the original sample, that is always the same, 0.962. Any questions so far? You can mute again if you don't mind. The sound is going to be better. Thank you. Okay, and please raise your hand if there are questions. So now we are going to look at what else they are asking you. The part C, similar of what we did. Basically, they give you the mass of the evaporating dish and sand, and you basically have to do always the same thing. So in our case, it will be this number minus the mass of the evaporating dish. That's very simple because we don't have to do it, just the data is given. And look at the sig figs, 3 digits after the decimal point. And the percentage, same way as we calculated before. And then they come in part B with a summary. We know this is just, we calculated at the beginning, but they ask you to write again. What is the mass of the original sample? So you know from the beginning, we had that. Remember? Let's look. Here, mass of original sample. We calculated that. So we have that number. And then here, they ask you, what is the total mass recovered? So all you have to do is add the mass that you calculated for ammonium chloride plus the mass of sodium chloride plus the mass of the sand. And that you get, this is the total mass that you recover. Then they ask you, what is the difference in weight? So basically, you started with 0.962 and you ended up with a little less, but not much. What is the difference? Obviously, 0.962 minus 0.948. And then you have that number, and they ask you to calculate the percent recovery of matter. How do we calculate the percent recovery? The percent recovery is going to be 1. This total mass, which is 0.948 times 100, divided by what number? Who can tell me? Is the mass that I recover divided by the original mass of the sample, how much I started with. And when I do that, I get 98.5%. So what it's important for you to remember is this. If you get, this recovery is lower than 100%, right? If it's lower than 100%, that means that you lost matter while drying or evaporating the sodium chloride. At some point, you lost some liquid because the weight is lower. Something splattered out of the evaporating dish. That's why the recovered mass is lower than 100. But there are some cases that you can have a higher than 100%. Is that possible? We don't create matter. So the only, or some of the explanation is that when you are evaporating the water, you didn't evaporate all the water from the sand or from the sodium chloride. And then when you wait, you think it's dry, but you are adding a weight that is not the dry substance only. It's the substance plus water. So that means you didn't dry enough. So this is a question that will come at some point in the report. In my case, because I have less than 100%, they are asking, select a reasonable explanation to account for the differences. There may be more than one possible reason that makes sense. Just select one. So in A, it says it is possible that not all water was evaporated from the sand. Is that our situation? No, because our recovery is lower. I mean, actually says causing the recovered mass to be higher. If in our case, it's not the case because we have lower than 100%. But the case B is even more ridiculous because it says it is possible not all the water was evaporated, causing the recovered mass to be lower. And that's an absurd. If you weigh the solid and the water, the recovery is going to be higher than 100%. It's only going to be lower than 100% if you lost matter. So in my case, I picked C. While drying the sodium chloride, the liquid boiled and some splattered out of the evaporating dish, causing the recovered mass to be lower. Any questions so far? So I will stop the recording and stay here in case you would like to ask me any question. I saw somebody a little late. If you missed something, I'll stay here. And thank you everybody for staying here.